Welcome to part 3 of the MX0MXO Buildathon. Today what we're going to do is we're going to solder up the main board. We're going to put the last of the components on, the two brass connectors, and we're going to put the inductor on and then link the link over where the 78L18 should normally go. And yeah, so anyway, so cutting to the chase, you're going to need a soldering iron. Now if I zoom out just a tad here for you, yeah, there you go, that's about as much I can do. Right, you're going to need a soldering iron. This happens to be a Weller 45 watt soldering iron. It's a kind of a professional grade iron. It's as old as the hills, and I paid, I think, 20 quid for that from a radio rally. Must be getting on for probably 10 years ago, and it was old then. I also have a very posh soldering iron, which was broken. Again, this is a very light wattage soldering iron, but it has a very fine tip, and this is a number 10 scalpel blade, and you can kind of see just how small it is. This is a very small scalpel. Right, so what else? Now I don't expect you guys to have any of those sort of things, and probably you're likely to have something like this. This is a typical Antex 15 watt soldering iron, and this is absolutely perfect for this. It's good sort of size, nice chisel tip on the end, readily available, and typically between sort of 15 and 25 quid depending. You can, if you've got a 25 watt iron kicking around, that will probably do, you know, because these aren't temperature controlled, bear in mind, so these will get quite warm. So make sure that you use a nice damp cloth, you know, a damp sponge to keep the tip clean, and it also keeps the tip from overheating. You're also going to need one of these. Now this is a very cheap, very basic AVO or multimeter. It measures DC volts. It can measure, this one can measure up to 5 amps. This came free with my Es'Hail DS 1054 scope, and yeah, it's very useful. It's very useful indeed, and we're going to need it today. What else are you going to need? Oh, we're going to need a power supply. Now over here, if I zoom just a little bit out for you, we'll do that. There you go. Over here, this is my power supply, and we're going to use that today. Now I started building this when I was about 10 years old, believe it or not, so it's quite old, and over the years it's a bit like Trigger's broom. It's sort of kind of it's got some of the same components in it that I originally put in, and over the years I've kind of added to it and made it safer, to be honest. I did do a printed circuit board in there myself, and then yeah, so it's a lot safer than it used to be, and made sure that it was all grounded and all that sort of stuff. But this goes up to 22 volts, so we're going to need a 24 volt or 22 volt, or like I said, as long as it's more than 20. Now there is another way of doing it. If you've got one of these things laying around, any sort of 24 volt or probably 19 volt sort of wall wart is absolutely fine. This will work just dandy. And what else have I got? Anything else here that we could probably use? Probably not. I mean, you can get those sort of things off of CPC or eBay or stuff like that, really cheap. But I got this sort of stuff you can get from boot sales. When you're wandering around and you sort of see a box full of these, you want to go through them, just see what there is. I mean, if you can get like a, you know, an amp or something like that, happy days, I'll tell you. It's just cheap cheap, useful junk box fodder. So let's start soldering this thing up. Right, where do we start? What should we do? Right, I think probably what I'm going to do is I'll solder in the regulator both regulators. What I will do then is we could potentially do a test to make sure that everything is okay before we commit ourselves further on, and we can do with that. That's a fairly straightforward thing to do. And where should we go? Now I'll tell you what, let's just go for it. I'm pretty certain I've been through all of this board, checked every single component against my list, made sure that all the components are inserted correctly. What I'm going to do is I'll get these things soldered in. So let's get a start with that. So first of all, put your iron on. Now this I did mention solder in the first video, I believe, and what I've got here is the remnants of an old RS roll. Now again, I've had this since I've only just really started. I had about 2 or 3 of these rolls back when I was about 19, and I bought them from a guy at work, and they were old again then. But this is just standard leaded solder, probably 5-core flux. Doesn't, again, you can get all sorts of these sort of things. You can still buy leaded. In my opinion, it's still a much nicer product to use. It's not as dangerous as people make out. Don't lick your fingers, wash your hands, and don't breathe the fumes. I mean, it's not rocket science. So yeah, you can get lead-free versions if you wish. You want as thin as possible. This is 1 millimeter or thereabouts, and it is just absolutely perfect. I think probably the rule of thumb for me is you don't want to go much thicker than the little leg that you're actually soldering on. Thicker solders are often used when you're sort of soldering sort of something like a PL259, and typically how I do it is I take the solder and then just sort of twist it together, and then you can get twice the amount of solder pushed into the holes and stuff very quickly. So let's our iron should be nice and warm. Now you'll see here my tip is a bit crusty. So what we're going to do is we've got over the other side here. I don't know if you can see, can't probably. Let's get rid of that. This is the Weller stand, and in here you'll see there's this kind of like gold sort of weird stuff. Let's see if we can get a better look in there. You'll see there's a like gold stuff, and what you do is you just give it a good old poking in that, and you'll notice that the tip goes all nice and shiny. It's a good idea to keep everything nice and clean. And as I say, if there are any solder police out there, I'm not interested. Right, now then, so I think probably what we'll do is we'll start with this big one here first, because it's just annoying where it keeps flopping around. Right, well, you don't want to carry solder to the job on the iron. That does not work. However, you do want to wet the iron, okay? And because the trouble is, it's kind of a catch-22 sort of situation. You don't really want to carry solder to the job, but you don't want to go at it with a sort of like a dry tip, because heat won't transfer from the iron to the actual material, to the actual component or the board, unless there's a little bit of unless it's a little wet, so there's something for the heat to transfer through. So you've kind of got to, just as you touch it on here. Now this board, by the way, is actually, this is all solid copper, okay? And what that is doing is acting as a bit of a heat soak. So this will take quite a lot of the heat away from the iron. Now what I've done is, you'll see here, okay, you'll see straight away it's working. I'm actually, as I add the iron, okay, I just gave it a little tiny dab on the end of the iron, okay, of solder, and that is enough just to make contact with that leg, and then it will start to flow, okay. And all you need to do is just, what you're looking for here is a really nice sort of joint that doesn't sort of like, you know, sort of like bubble up. So let me try and draw it for you so you can see. I've got a pen, probably not, I've got a pencil. Oh, I've got a pen, there you go, it's a bit darker. What you're actually looking for is, if that is your, okay, leg of your joint, and you've got your substrate or your board, okay, what you don't want is a bead to go like that, okay, that's bad, you don't want that. Okay, what you're actually looking for, and what else, oh, sorry, we'll do what you don't want really first, and also you don't want the solder to kind of sink down and leave like a void. You can see that, sorry, I'll just get this off of there, there you go. So you don't want it to sort of sink down and sort of leave a void either under the board itself. What you're looking for is that kind of is the golden egg, okay, where it kind of, you get the leg going through the substrate. You want that really lovely, that sort of shape, okay. I mean, obviously that's a bit exaggerated, okay, and then you can just nip the component off there, okay, and that's a nice joint. And what you need is the solder to go down the hole as well, and you'll see when you've got it just right, you'll probably see on a, especially on these sort of boards where there's a, and the hole goes right the way through, okay, you'll see that there might be a little bit of solder pop out the other side. And that is why, if you make a mistake, okay, it's so hard to get the component out. You've really got to get a solder sucker and just suck that stuff up. And if you've not seen a solder sucker before, if I can find mine, it's one of my many. This is a solder sucker, and what this does, okay, is you push the little thing down, push the end, and it flicks up, and it causes like a suction on there. And what you have to do is heat the thing up and then suck the solder up. But what you've got to try and do then is you've got to get this to suck it all the way out so you can get the component out. So please double check before you solder. Right, so what I'm going to do is, I won't hang around. If at any time you want to ask questions, I think James is going to do this kind of semi-live. If you want to, you can just ask the question. I think James can stop this video playing back, and then we can, you know, maybe to have a little chat with you if you're a bit stuck. So give my iron a clean again, and I'm just going to get cracking on this and just get this all done. Okay, I think I've got the camera somewhere where you can see it and I can also see it. This has been a bit of a fiddle, but hey ho. For those of you that are interested, I'm doing this with a mobile phone on a little stand. Now this is very, very clumsy. Now what I'm going to do is exactly what I said earlier on, just a little bit on there. This is a bit awkward for me, but hey ho. So what you can do, if you want to, you can stick this down with a little bit of heat of blue tack or sort of something like that. Now I don't actually have any, but it is nice and easy if you do that. So all I'm doing is just taking my time and just dropping those little solder things in there. And what you can do as you go as well, let's get that in there. What you can do as you go, you can take some of the legs off just to make it just a little bit easier for you. Okay, so we can do that now. And again, like I said, these little tiny flat cutters are an absolute godsend for this sort of stuff. And all I've done here is I'm just taking these off just to get them out of the way, the ones that I've done. Okay, I'm not taking any of the others off. Now this is just a tiny bit, a tad awkward for me, so like I said earlier on, if any of the solder police are out there, then don't slam the door on your way out. Right, now then, so let's see if we can get that in, that one in there. Doing it like I said earlier on, if you've got sort of something that you can tape this down with, then absolutely brilliant. And I might actually have to do that in a minute because it is moving, it is making it a little bit awkward. But if you could see how I'm doing this, so that you guys could see, you'd understand. I'd normally do this probably in a PCB vise, to be honest. But all I'm doing now is just taking this, the leads that I've soldered off, so and that'll allow me then to get just a clearer view on what I'm doing. And that one there as well can come off. I'm not going to cut this one off. I'm not going to cut this one off here. Okay, I'm going to cut this one down just a little bit. Okay, and there's a jolly good reason for that. It's because I want to attach a wire onto this one, and this one here is the input, so I want to attach a wire to that one as well. Sometimes if you've got like a board where it's got quite a few components on, you might actually want to just attack one leg on each of the components, and that kind of helps keep things in place. But what you can do is you can get sort of some of this sort of stuff, this blue sort of tape, and what I tend to do with it is, if you get like one particular sort of component that is a little bit on the tricky side, what you can do, sorry if I can get hold of it, I'm looking through this through a magnifying glass, you can take the tape and then just tape it down in place, and once you've done that, then it's great. So let's get rid of those. If I can get this to stay still, that would be useful. It doesn't want to, but that's all right. I haven't got anything I can grip it down with, but I'll solder on in the interests of doing the video. So again, all I'm doing, okay, with a clean iron, is just a gentle, okay, just dabbing the little thing on. Once you get the hang of this, you can go quite quickly. And this one is the component that I did wrong. This is the ground pin. That might take a bit of heat. Look at that, that's beautiful. And that is all of our components soldered in. That one there looks a bit iffy. I don't know if you can see that. Let me see if I can zoom in just a tiny bit more. You'll see, well, I'll do it. That one there, see, it's a bit sunken. So what we'll do is we'll do that one again now. And for you, so we'll just give him a little tiny dab. It is quite a big component, that one. It takes up quite a lot of heat, and especially on the ground pins. Okay, this one is the ground one, and it does take, even with a 45 watt iron, it's taking a lot of the heat away. Always put your iron back nice and clean. And that is that part sort of done. So what I'm going to do, I'm going to sort you back out again here with the camera. If I can do that, if it'll work, let's put it on that. Right. There you go. Sorry about the wibbly wobbliness. And there you go. Right, so what we've got here now is the board is all soldered up. So what we're going to do is we're going to take the cutters and just trim those off. You don't want to leave, if you can, you want to take something like a little bit of alcohol, and then just make sure that there's no flux. You don't want to leave sort of flux around, so just take an alcohol or something like a, you know, glasses cleaner or something, that would do, and just to have a little look under the microscope or the magnifying glass to make sure that is all pretty good. So there we have it. There's my component, which is in the wrong way round according to the silk screen, and that is pretty much that. Now then, next stage. I hope you like these videos. These have been quite interesting to do. Never done them before. What I'm going to do here is, if you take the back end of a brush or sort of something that goes up that coil, okay, you can then move him out of the way. If you take that now and just lay it on something hard and just scratch that enamel away. Some people might not like this noise, by the way, but that's okay. I don't mind it. Don't cut your fingers. Okay, and we can just get that last little bit in there. It's a bit hard to get all the way around. That's the fun of the fair. Just turn that one round. There you go. Just going to leave it on the end of that brush for a moment, and what I'll do is try and get this right. Again, all I'm doing is wetting the iron. Okay, I'm not carrying solder to the joint. All I'm interested in is it just want to tin that cable. Okay, and this bit actually is the fiddliest bit ever. You want to make sure that you've got as much of that stuff off as possible, and just work it on. Right, so it is a bit fiddly. You can just see what's happened there, just enough to tin it. And then what you're going to do is put that through your board. Just make sure just make sure that is in as straight as you can get it. All right, and this may not take very well, but we'll see. I'll do this then that's got it. Not a great joint, but yeah, that's not a great joint, that one. So we'll just work on it, it's not a problem. So these are the worst, you know, anything with enamel on it is just a pain in the neck. And that pretty much is that. So we'll just push that back in there, just give that a little squeeze down so it's out of the way. Okay, and then just give it a neaten up, and you can just see there that where the solder's gone. I don't know if you can see the solder has just gone through on the inside, just in there. Okay, so you know that that's actually got it, and we can check anyway in a minute. It's not the best joint on the other side though, I will admit, but you know, we can straighten it up in a minute. That's not a biggie. Certainly it's good enough for the testing stage. We can straighten that up. And also you want to try and keep your little sweepings or your little cuttings off the floor, and where you can actually throw them. And I like these silicone mats, by the way. I think they're really good. If you haven't already seen them before, they're like solder proof, so you can hit them with your iron. It makes no odds, they don't melt. But the other thing is as well, once you've done this and you've got all your bits and sweepings, you can just pick them up and just put them, roll it up and just put it all in the bin. Right, so the next stage is going to be just putting these bits in. Now these will take a lot of heat, so the more heat you can put in these, the better. So yeah, it's a bit of an odd one, this one. On here you'll see there's marked SDR. Let me try and zoom in just a little bit closer for you. You'll see you've got SDR marked there, and here you've got RF plus DC. Now that is the side that comes from the LNB. This side here goes to your SDR. Obviously we want to protect the SDR from DC, which is what this is doing here, this DC blocking capacitor. Now I've made this in such a way, or I've given you enough sort of stuff here so that you can't get it wrong. Okay, there are two things here. So what we're going to do is we're going to put the SDR one in first. So look for the SDR and then look for the one with the nut on it. So you get this one here. Okay, and what that one's going to do is just pop in there like so. Now you will need a bit of tape probably at this stage to tape that one in, because this one is a right little tricky sausage. What that was. And what I'll do is just stick a bit of tape down one side there. Okay, and then just take that over the other side like so. Okay, just hold it in. So there you go. Now what I'll do is I'll just turn that over. Now you'll see that the pins are pretty much, everything is nice and flat on the board, and I'll just take that to there like so. Now this might take a bit of heat. I'm not gonna solder all of the 4 pins. There's no need. All I'm going to do is just solder 2 of them. The one in the middle will solder the best. So what I'll do is I'll do that one first. Okay, and that one's soldered beautifully. Now these will take just that tiny little bit more heat. So what I'm doing is I'm just touching the end of the iron. Okay, and now I'm letting the heat soak in. Okay, and then I'm taking the solder to the actual outside of the work. Okay, and then we'll take that one there. So again, all I've done is I've just touched the end of the iron so that there's enough solder on it just to help the heat transfer, leaving it for just a few seconds and then just touching that in. Okay, and that's beautiful. It's done really well. Okay, so there's that one. This will be very hot, please do not touch. Okay, so that one is the SDR one. Okay, that is mounted, and what we'll do, okay, mind your fingers please at this stage. It's like I said earlier, it's very hot. If you've got a smaller iron, all it means is it's going to take you just a little bit more time. Okay, just to let the heat soak into the job. Now I've been doing this quite a while, so You know, I'm quite used to it. It's not I mean, the clue's in my call sign for those of you that know. I've been welding and fabricating for quite a lot of my life, and back in the day I used to make fryers and copper and brass lamps and lanterns and all that stuff for a coppersmith. Come on. Sometimes if you heat this up, by the way, the solder will stick. Don't panic, just nip it off. It happens. All I'm doing here is all I've done is I've just put the iron in there. Again, just wet the end. Okay, and that starts the process off. It'll start to transfer its heat. And time is the king here. Just let the heat soak in. All right. Yeah, so I used to make lanterns and all sorts of things, and I eventually went into R&D, into NHS and commercial signage with solar and stuff. But that's another story. So there you go. This is pretty much now a finished bias T. The only bit that we've got to put in is my little bodge up, and here. Now this is probably going to be a little bit difficult to do, but I can grab a pair of pliers. Okay, so again, all I'm doing is scraping that enamel off. Like so. And again, if you guys want to stop the video at any stage just to sort of catch up, like I said, I think James is going to do this live. I think he's doing it sort of something with one of the TeamViewer type programs, and I can't remember the name of it, but it does mean that you guys can chat all at the same time, if you want to stop the video and just ask questions, then you can. It's actually really rather fantastic, I think. So there you go. And then what we'll do is we'll tin that up. What I'll do is I'll take a bit of tape, just a longer length. Okay, grip my pliers with my fingers at one end, like so, and then just put the tape around the handles. Okay, and that's just that holds it just enough for me to get a little bit of solder on. Hopefully the enamel will be enough of an insulator to take it away from the cold of the pliers, because obviously that will take all of the heat away from that joint. So what we'll do is we'll just get that on there like so, and we'll get that bit on there like so. Clean the iron, and there you go, look at that. And if you've kept up so far, and then well done, as I say, because you know, it's all a little bit fiddly. Now you can see what I've done there. Just put a little bridge. See, just like so. And what that's doing, that's shorting the input through to the output of what would have been there. So what I'm going to do is just turn that over that way. and I'll just pop those two joints in like so. Right, and we can nip that one off and that one off. Now it's not, there are one or two joints on there I'm not particularly pleased with, but like I said earlier on, what we can do is we can come back to those. I like to try and keep all these sort of things nice and straight, so you know, I just a little bit of fiddle farting with this just to get it perfect. Now we can test, and fingers crossed it's good. So what I'm going to do is we'll give you a little bit of, let's zoom out there for you and turn that back round like so. We'll bring in Mr. Power Supply, and like I said earlier on, we need about 20 volts to get this to perform as it should. We plug back in there, red in there. I would always recommend, okay, at this stage, using a current limited power supply or source. Okay, now there's lots of ways you can do that. You could potentially put a light bulb in between. Okay, if there's a dead short in this circuit somewhere that you've inadvertently done, then the light bulb will light up rather than the circuit blow up. However, you'll find that the current obviously is what the light bulb will be. So if it's an amp, then obviously there will be an amp rolling around on here, and if it's a delicate component in there, then obviously that's a bit of a problem. Now this is a positive regulator, so what we need to do is we need to take the ground pin, okay, and like so, very carefully without shorting things out, and you can, if you want to, you can put a little bit of tape between the two, and then we'll take the live. Now I've set my power supply on about I think 5 volts here, okay, and then I'm going to connect that one up to that one, okay. I'll just use a pair of pliers just to hold that in place. Now what we're looking for is we're looking for DC voltage of about 12 volts. So what I'll do is I'll slowly wind this up. I've got a feeling for heat. And there isn't any at the moment, so that's good. I'm going to take the black through to ground, which is these outside of these things are grounded, and what we should see here, if you can see that, okay, so let me turn that off actually. Is that better or worse? It's a bit worse for me, but it might be a bit better for you. You can see it. I think you can see it there. So what I'm going to do is take that edge, it's a bit that's all right. Right, so I'm going to take this outer here, okay, and then on this port here you'll see there's a 12 volt side and an 18 volt side, okay. Let me zoom in for you on that one so you can see, but actually it's not a bad way to do it because I can move that just a little bit over and you can see everything. So here, okay, you'll see there's a 12 volt side and an 18 volt side. If I touch that one, I get 12 volts. If I touch that one, I get 18 volts. And that's good. Right, now then, how do we then test whether or not this circuit is actually working? Well, if we take what we need to do, unfortunately, is we need to switch between one or two of these. Okay, so this is where a switch would go, and James and I used, because we were operating mostly remotely, we were using a relay board, and what we did is we tapped into this interface here, okay, and we switched between ground to the common in the middle and one of the voltage pins. Okay, so it is either the 12-volt rail or the 18-volt rail. Okay, and then all we did is we switched it to that. Now I'm going to cheat somewhat, so bear with. Right, what I'm going to do is this part here, okay, which I haven't really explained. There are 3 holes here. Now you need this center one is a common connector, okay, and that goes off to the circuit itself. Now here you'll see that you've got 12-volt side and an 18-volt side. Now how this circuit actually works is that obviously we've now linked this through, so that's kind of as if there was a component there, but there are 2 rails, okay, and I did this because it's what I had in my junk box at the time. Okay, you'll find yourself when you're doing these little circuits, you kind of you tend to work with what you've got. Okay, sometimes it's if you're going to do like a real circuit right from scratch, then you can actually pick up you know, you can buy components to do whatever you need to do, and you can design things that way. But sometimes you just got to work with what you've got, because these days components aren't cheap, and you know, sometimes you might have to buy a few components to really sort of make it worth your while, and you know, that doesn't always work. So sometimes we're robbing things out of old circuits and stuff like that to, you know, really to get components. So what I've done here, okay, is I put these 3 holes in. Now you only need 2. You need the center one constantly, that's a common, okay, and then the other 2 there you either need one or the other. And what that does, it flips the LNB virtually from like that to like that. Okay, now inside there are 2 antennas. There are 2 antennas, and they're slightly spaced apart, and they're at 90 degrees to one another. And there are in here, I think there's probably 2. You've got like a changeover circuit, and what that does is it basically works on voltage. So when it at 18 volts it goes one way, and at 12 volts it goes the other, and that's just the basically the little amplifier that's inside the RF amplifier. But to make that work, what I'm going to do is I'm going to solder some pins on there so I can get to it really easy. So what I'll do is I'll do that now without any further ado, and just get him on my fiddle fart with that. It's actually not that easy to do at this stage because it keeps wanting to fall out. So I use Mr. Tape and just pop a bit of tape over the whole lot like so. It doesn't look pretty, doesn't matter. Okay, and again, any of you police out there watching this going, you didn't do that right, you didn't do it, I don't care. Okay, tell it to someone that does. Okay, so we got that right, so let's get that in there. I'm going to do the center one first, just to kind of, and again all I'm doing is I'm just dab just a tad on the very end of the iron. In fact, I didn't need to do it that time, and so that the heat transfers. Let in the joint and then add in the solder. Okay, some people will say, oh no, you have to sit there and wait. No, you don't. Just do a tap, let the heat go, and then take the joint in. Clean the iron, back in the ding dong. Right, now that is your little connector block attached. Like I said earlier on, at any stage you can stop and ask questions. That's not a problem. Now what I'm going to do is I'm going to connect. Now you can use a computer jumper if you want to. That's a very good way of doing it, and you can just jump to one to the other. But I'm using this Arduino cable to link from one side to another. And what I'm going to do for the test, okay, I'm going to put it to the 12-volt side. Okay, you'll see that there is one pin spare. Okay, you do not need to connect both sides because you'll blow your LNB up probably. So I've not put any protection in that, so you're on your own with that one. So it's either that side or that side. This side's 18 volts, this side is 12 volts. All right, so what we'll do is we'll do the test with the 12-volt side. Okay, and what we should do now is when we connect our power supply up, let's turn that down. Always try and turn your power supply down to next to nothing if you can, or turn it off while you make the connections. Okay, now he goes on that connector, and then we take our negative connector, connect him on there like so. And all I've done is I've just put a little bit of paper or a bit of tape between the two just to help protect it. Okay, and then we'll wind that up to the 20 volts. Now what I'm looking for here is, if we flip this over, okay, if it'll go, and if you can see that, I'm looking for, okay, if I take the outside of that connector, I'm looking for 0 volts there. Here I'm looking for 12 volts. See that? So this side here, okay, is going to the SDR. Okay, so we don't need any voltage on that at all. In fact, if we have voltage on, there's something wrong. We need to find out why. Okay, so just onto the negative is going on to the outside of that SMA connector. Okay, and we're going to the center pin of that little lot, and we've got absolute 0 volts. But on the other side we've got 12 volts. So actually that's working. Now if we then take that pin, put it over to that side, then we're on the base current, or the base voltage. We can see that. Again, we'll take the outside of that. We want to see 0 volts. We see 0 volts. With that side, we want to see 18 volts. There's our 18 volts. So by swapping those, using the common lead, and then swapping the outer one over to one or the other, that gives us our 12 and our 18 volts. The project actually works. Like I said before, because there's 18 volts, just by the way, a little note on multimeters. On a multimeter, you'll see there are 2 ports. If you've used it for current, like so, it's always good practice, okay, to pull that out and put it in the standard volts when you switch it off. If you forget to do that, that's a dead short, okay, between those two. If you were to go and check a voltage like we have now and accidentally leave it in that mode, you'll just short the project out and blow it up. Not good. Right, so where were we? So yeah, I think we're pretty much done. Like I said before, 18 volts drop. Right, so let's turn that off for a sec. So we have got a base voltage of 18 volts because of this big regulator here. So we zoom in for you just a tad. And here, okay, this regulator here okay, is 12 volts. So you've got a difference of 6 volts. So this is turning, in fact, actually there is about 0.6 of a volt lost in one of these sort of components. So for this to pass 18 volts, you've got to have 18.6 volts, and the same with this one, you've got to have 12.6 volts for it to pass 12. So this here is giving us 18 volts. So we got 18 volts on the base, okay, and this here is using that 18 volts, okay, to actually give it 12. So you're losing 6 volts or 5.5 volts into heat, okay, straight away, or 6 volts into heat. Then add to that just a little bit of load, and this is capable of about 100 milliamps, but it's a very well protected component. It's actually got lots and lots of thermal protection in it, and it's quite a resilient component. However, a single one of these, a single output one of these is about 85 milliamps, okay, which is perfectly good. This would be perfect good for it. But the twin is about 110. Now it is pushing it, but we've had one running on it now for about 3 months, and yeah, it's absolutely fine. It does get quite warm though, so yeah, just be warned. When you come to connect your power supply, I presume that you'll be using, or assume that you'll be using, sort of something like, one of these, your wall wart, okay, and that's perfectly okay. You're going to need some tiny heat shrink, which you can get off eBay. Work out which one of these is positive and which is negative. Like we said earlier on, put a little bit of heat shrink on and just solder the connector on to there. So the negative goes to there and the positive goes on to that one, and then heat shrink the whole lot together. All right, so it's nice and safe. All right, but that is pretty much the project done. I hope that you enjoyed it, and any feedback you want to give on the tutorial, then fine. You can do, if you're watching this on YouTube, then you can leave comments below. You can certainly tweet the guys, MX0MXO on Twitter. You can go to the Chertsey Radio Club blog, which I'll put the links below in the description, or if you already know anyway, because you're watching this on the Buildathon, then excellent. There will be more, and we want to do more. So again, feedback would be useful on the course. Yeah, so if you want to see anything, if you want us to build anything, if you want us to do it, or if you're a kit supplier and you want to give your kits a bit of a plug, then please, again, you can contact me, or you can contact the guys. Just let them know just what it is you've got and would like to help us with. Yeah, so thanks for watching. See you next time.